Hi, I'm Marty Johnson from 3D Systems. I'm here to introduce you to a set of module training we put together for your Figure 4 printers. This module training is to help to provide to you what our success is in the lab so that you have success in your endeavors with your Figure 4 printer. And this is module 3. This is your 3D Sprint toolbox and parts setup. And if somebody comes up and says, how can I learn how to run this system? I say you definitely want to see. I think it's real important to go through these modules, and they're set up such that you've got the safety and the understanding of how to do the safety. You've got a basic understanding of what your overview and how this printer works. But now let's really put some rubber on the road and go in and see, how do I set my part up and how do I get the best success out of my printer? And understanding what's in 3D Sprint is really critical. And so it's so critical that the next 4 modules are related to using 3D Sprint to set up our parts per our applications and intents, and identifying what tools are available. So this particular module 3, it's the basic tools and setup, but there's a lot of information here that will give you success in printing on your Figure 4. So let's just get started. I'm still Marty Johnson. We went through this earlier, so I'm going to skip through to the next slide here and look at our training modules. And you can see we are at module 3 for basic training. And as I mentioned, the next 3 modules are going to be 3D Sprint Intermediate Toolbox, 3D Sprint Advanced Toolbox, and 3D Sprint Production and Repetitive Printing Tools. So I would suggest doing these in succession, and there will be videos posted on the info center for these, for those that miss them, because there's a lot of information here. And I know we're already using these as group training that people are doing internal to their own facilities to be able to understand, so that they're, as a team, they understand what's available and they all can get the best success out of their printer as soon as possible. The purpose of this module is to provide a basic understanding of the toolbox in 3D Sprint and how to use those tools that lead to printing parts for the desired part, intent, or application. And so the goals of this are to understand the basic layout of 3D Sprint, to understand where all the help links reside and content of each, and this is very important. I couldn't highlight that. I should have even put it in red. And understand the basic part setup in 3D Sprint, understand the basic use of the Prepare tab in 3D Sprint, and then how to send a print over to your printer. Before we get started, I will show you that the 3D Sprint software can be downloaded at the link below. There's other helpful information that can be found on this page, such as registration and activation links, 3D Sprint support links, installation, and system requirements. In fact, let me take us to that. And this is where what you'll find at that link, and how to get started registering your machine, downloads, anything that you need there, installation instructions, requirements. A lot of good information on this page and this link. So let's go to our demo, and we're going to go into 3D Sprint now and set this up, and we're going to walk through and set up some parts and look at how 3D Sprint is set up and where things are, and see what we can do to make this and make you successful. To start on the basic layout, this consists of preferences and controls. You've got the print and prepare tabs, the Q tabs, parts list, active setup information. Let's touch on all of this so that people understand what's available. We'll start at the top with the icon for preferences. On the preferences tab, and I'm not going to go through every detail, but because a lot of that is available in 3D Sprint, and we'll see that in a minute. But we're going to go through here and just touch on some highlights. One of the things here in the preferences is this is where you get your localization and units. So those can be set up here. In addition, down at the bottom, this is 2.10.1.1006. That's your software version. If you ever have to make a call, your 3D Systems service representative is going to ask you what version you're using, and so that's something that you want to have handy. There are other defaults in here that can be set up as well. Next is a question mark, and I will say anywhere there's a question mark, I would click on it in this system. The question mark is going to take you to helps, and there are quick links to help online. So, and it's pop-up help. So if I've got 2 screens, I can look at my help, and I can still be doing things on 3D Sprint at the same time. with a couple of monitors, and it's a really nice tool to be able to not have to keep all of that in one place. But when you go in and click on that help, this particular help, and this is the main help on the main screen in the top right, you'll see a lot of the things we're going to talk through here. This will label out and tell you navigation buttons, command panels. You can go through the commands and you'll see each one of the icons that are on the panel. You'll see what they do. For instance, if we click on Orient, there'll be a video in there of how to use that particular icon. There's going to be terms or define and any other information that you'll need to be able to know what to do with that icon and what it's available for. Again, you'll see that for just about all of the icons in there, there should be some kind of help. And then there's some extra information here on selecting parts, navigation tools, and things like that. So again, this is the help button that's up on the right. A lot of useful information. If somebody's first starting out with 3D Sprint, I would suggest they click on that and just take a little stroll through and see what's available there. The next place we're going to go is the parts list. The parts list and properties are here on the right-hand side, and let's open a part and give you an idea of what that looks like. We'll just bring a part in here. This part's in, it's got blue on the outside. That means it's within our boundaries. We should be in pretty good shape. You see a green check mark. That means the part is verified. We can go down to the properties. In the properties, you'll see this. You'll see the name of your part. You'll see how many triangles your part has from the STL file. You can get volume and surface area information. And also important are your extents. Now note your Z extent will start at, this extent starts at 13.27 millimeters. So this is telling you the extent of your part. But there's also 79.28 millimeters is the maximum height of this part or this print in the way it is oriented right now. If you reorient that, of course, that's going to move. Also on the bottom right, you've got your Prepare, where you can go to the Prepare tab. We'll go back to the Print tab, and we'll touch base on the Prepare tab in a minute so you can see where some of the functions are there. And this is where you prepare your file, and you go print the file, you slice it, and it will execute the print based on your setup. Also at the bottom right is your active setup information. This is running a virtual printer of the Figure 4 standalone, which means I did not select a specific printer to slice my part. It's got tough grade 10 material selected at 50 micron layer thickness. It's in standard mode. You'll see the XYZ configuration. There's a percent here. The reason that's not 100 is in your default modes for each material, your setup in 3D Sprint will take into consideration your scale factors. And so what that means is if you have different shrink and scale factors for different materials, you won't set your part up outside the boundary. So it's going to do that adjustment for you. And it's a really nice tool to have, especially when you're putting a lot of parts on a platform. And then we're going to go up here to the Printer tab. One thing, this Print tab, this is your main working space. I would say for a customer, this is your portal to the customer right here. You've got your help menus. This is where you're doing all your manipulation, your setup, your part handling, whatever you need to do. That's done in this particular tab. If I go to the Printer tab also, you'll see has a help button. The Printer tab, if I go to the right, we'll click on the help button. There's a video that takes you through some different things. It'll go through in detail some of the items we're going to talk about and highlight. And you'll see that in the Printer tab. Terms and definitions, things like that, all will be here. Another thing in the Printer tab is there's hot links within the Printer tab itself. And what I mean by hot links, when I drag my cursor over a machine, I'm going to see in yellow best practices. One thing I'd like to emphasize is whenever you see a highlighted best practices tab, it's worth clicking on it. For the standalone printer, I'm going to go here and click on this best practices. It's going to again be a hot link. This takes me to the user guide. This takes me to a quick reference guide. There's some things on 3D Sprint. A lot of useful information at the hot links, and this is for the printer. Once I select my printer, if I go to the material, and we talked about this before, this hot link is really going to be your friend. This is going to go to, and we'll just choose Alas Black 10. Click on the best practices hot link. It's going to take me to a table. This particular table for this material, and it has all the materials for the printer in there, but it's going to go to that spot on the table, and it's going to have some tips. This one talks about using orientation to minimize large cross-sectional areas. For full platforms, print quality is best in premium mode, or slow down the interval pause time to add that to 1 or 2 seconds. You're going to get some information here for each of these. There'll be some things, again, there's another caution about do not press down on the film when stirring for things that need to be stirred. In addition, there's more videos that are available for best practices and how to set up parts. They'll be real similar to the things we discussed today. There's a place where you can go in. Oh, we got rejected on the link there for our best practices that you could go in and print out that will talk about handling cross-sectional areas and some of the things we'll discuss today as well. There are resin mixing instructions for this material at the top, tough gray tin. If you have a new bottle, then it's recommended to mix that for 1 hour after you've used it once. Then after your first use, and then before you pour in, you may want to roll that about 10 minutes. The difference is this could have sat on the shelf for several months for the 1 hour, whereas after you've used it, this is a more recently mixed material. In addition, there's part cleaning information. If you click on that, there's a post-processing guide. A lot of information about post-processing your materials. At the bottom of that, you'll see more links to cleaning resin tray, curing the parts, removing parts from the platform, some more detailed information there. And lastly, you'll have part curing time, and that will vary based on your material. The tough gray tin suggests 60 minutes, 90 minutes for the tough gray 15, or 45 in the Alas black 10. And again, these are in the LC3D light box that we sell for curing parts. So a lot of information here, and that's found again by clicking on your best practices hot link for your material. If there are multiple colors available for that material, that will be found here. And if you go to your print mode, the print mode down here, you're going to see highlighted in yellow. This says default. What default means is a couple of things. This is the best combination we found for print quality and speed. And so we try to balance those out, and that's where we start. You'll see in the build styles in a minute, there'll be other things under advanced modes. But as a start, this is what you'll see in the default. So if you see claims on print speeds and throughputs and accuracies and things like that, they're done at the default mode that you see here. And so this particular material has 10, 20, 30, 40, and 50 micron layer thicknesses. That may not be the case. The Flex Black 10 is only 30, 50, and 100. So it's dependent on the material. And let's go back to our tough gray 10 and go to standard mode. So standard mode is default for your tough gray 10 again. Most things are set up for defaults will be in your standard mode. Now let's talk about the difference. Most materials will have draft, standard, and premium modes. So let's talk about what's different between those. Your draft mode is, of course, going to be a high-speed mode, and it's pretty good print quality. But it's something that you want to say, I want a fast print. I just need to check this out. It's a prototype. Let's blast it out and see how it looks. If I go to standard mode, that's an intermediate speed, and this great print quality. Again, this is where we go in and balance out speed versus print quality. If you go to premium mode, that's going to be a moderate speed, but this is your best print quality. And the times you would use premium mode are a couple of places that will help you. If you've got large cross-sectional areas, which we'll talk about more in a little bit, then you'll probably want to go to premium mode because it's going to allow for your material to refresh a little bit better. If you've got a lot of different parts, if you've got a full platform of parts that are, say, 20 millimeter diameters, if you've got a full platform like that, you may want to print that in premium mode as well. So you get a really good refresh rate on your material as you go through. And so it just depends on your intent, your application, and what you set up. You may find that in draft or standard, you can't, or even premium, you may not see a big difference in your part. But there's going to be parts when you set up those kind of cases that you're really going to see the difference. Features and things like that from draft to standard, you should see a difference, of course, as well. But really want to consider that. In premium mode, again, just to reiterate, if you have large cross-sectional areas or a really full platform, you might want to consider using premium mode. So let's just set that, and we'll go back up to our toolbar, and we'll go to the file. And this is where you can save as, or close 3D print files. You can also import and export STL files as we did. And of course, you can close your part here as well. And let's just close this part. Do you want to save your changes? No, we won't save this one this time. Now I'm going to bring back in another part, and we'll look at, go to my auto place, and let's set that in. Now this part's is highlighted with a red border, and you can see up here at the top right, it's got an exclamation part, and I go do my mouse over. The part contains open boundaries. So I'm going to want to fix this part before I print it, because I'm going to have some problems if I don't. So let's go to the Prepare tab, and I can already see there's a triangle missing here. It's highlighted in yellow. I want to try to fix that. So let's go to the Fixed icon. Again, the Fix icon has a question mark. If I want help on what that means, there's a video that will pop up, and will go through and tell me what I see when I see purple in my part or yellow in my part. It will give me a definition of terms and let me know all the things that I need to know on the Fix icon. For this particular one, there's one open boundary. We can see that, and there's also some self-intersections with triangles in here that you can see in the purple. So let's just fix that. And you can see that that was really fast because that was a really simple fix. Some parts may not have that. But if you have scan data, you're going to run into this a lot more. I would always bring a scan part in here and take that out, because a lot of times scan data will have a lot of noise shells and open boundaries and self-intersections. So this particular part was a CAD file that just happened to have an open boundary, and you can see that it fixed that, and now it's highlighted in blue. There's some other things that you can do in the Prepare tab. You can reduce triangles. You can mirror and offset and split your part. You can extrude geometry out of your part. You can generate geometry and add here. But one of the things that I really like about the Prepare tab is if I'm doing multiple parts, let's say I want to print 10 of these parts and I want to print them all at the same time and I want to know where they are, then what I'm going to want to do is go in and maybe engrave that part and set that part up such that I know which one was printed where on my print layout. So let's do a view and choose this from the top. And I'm going to choose the plane I want to do the engraving on. My window's a little big, so let's shorten that up here. And we'll go into the text and just say part 1. I'm going to have to move that over a little bit because it came off my part. That looks good. I think I like the font size. I'm good with that. If I want the font smaller, I can simply make my window smaller, and that will help me decide how big to make my font. So it's a nice automatic feature to have. And so I've got that set up. I want to engrave this, so let's just hit engrave, and we'll apply it. And I'm going to close here, and let's rotate this over. We'll hit the sharp edge where you can see now we've got an engraved part. And you can control the depth and things like that, but there are a lot of features here that you can use to manipulate your part. But again, this is one I just want to highlight because we use this quite a bit. And then once you're done, you can just add that to your print. It's coming in red because it's beneath where we generally have set up in the build style. So I can go to auto place, set, and you can see we're red, blue around the outside again and ready to print. And then lastly, the Q tab. This is where if we slice a file, we'll keep things in the Q tab. We can add files here. We can do some different things in the Q tab, and we'll touch on that as we slice prints and move forward. So let's go in and look at some of the other buttons we have here and set up a part that we want and move around and see what our intent is. So let's go back. We'll close this. Do I want to save? I won't save those changes this time. Normally I would, but let's take our import and let's bring this file back. So again, the first thing I want to do is I'll bring this part in and I want to identify the intent and application of the part. And as I mentioned before, it looks like we've got a datum surface here. I want that to be pretty flat. I've got screw holes that come in the top. I've got 3 different larger holes where I'm going to bring tubes in as a junction, and I've got a sensor in the bottom. So to get this started, let me just take this. We're going to use the Orient function. We'll go to manual. Let's set this flat where we can really take a look at it. And let's view this from the top. Now, one thing you can do with your transform button, and we're going to use this quite a bit here. Let's just center this in the system here. And let's take a look at this part. Now, one of the things that I really want to stress when you're using your Figure 4 this is the figure 4, this is the modular, even the Fab Pro setup, you really want to limit your cross-sectional area. That is one of the first things you'll get from a successful part build. And so one of the ways to do that is I'm going to go over here and I'm going to turn on my clipping and I want to choose Z. And you can see my part's gone, but I've got this blue XY plane around the bottom. And so if I start to move that up gradually, you'll see this larger cross-sectional area in red. And I'm just going to move this on up and you'll see it get smaller. And then you'll go up and it's going to get a little bit bigger and then it gets small again. Well, I will tell you, if I want a really nice looking part, I want to try to get rid of this big cross-sectional area. And there's a couple of things. When you deal with materials, one of the things you have to deal with is differential shrink. We are using membrane printing, so I want to be able to get the same amount of refresh rate all the way through my part when I'm printing with my material. So what I'm going to need to do is rotate this part. But I just don't want to rotate it blindly. So one thing I know is we talked about the intent of the application. We've got this larger cross-sectional area. So let's kind of set this up such that we can optimize on that. So one of the first things I'm going to do, let's turn the clipping back off for now. I'm going to click over here on the right on my down facing. I'll leave the angle at 45 and let's set the number of grades to 10. And when I turn that over, what I see is it's highlighting my down facing surfaces in red, and you can see there's a little gradient here that it's not a 90-degree down facing, but it will check it up to 45 degrees relative to my XY plane. So I can see kind of where I may or may not want to have supports. So one of the things we talked about when we set our part up is we've got the datum at the bottom, we've got the holes in the top, we've got the tubes coming in the sides, but one of the things we really want to maintain is the integrity of where our sensor is going to fit into these features. And that way our sensor will work properly. So what I'm going to do is I'm going to go in here to my transform, and let's just start by rolling this back. And that'll help us with this cross-sectional area a little bit. And you can already go in and see a lot of that red's gone. So we got rid of our straight down facing surfaces, and we're a lot more self-supporting in what we do. And so I don't like being over that far. Let's kind of come back just a little bit. One thing I will show you is if you go to your snapping, it's set at 10 degrees. I'm going to set that at 1, where I have a little more granularity in how I move that. And so now that I've set that up, that's going to help me with my cross-sectional area. Another place I can optimize, and the reason I rotated it in that direction also is because I've got these features that I want to maintain. So the fewer supports and fewer things I have to do to these features, the more accurate and the better integrity of these are going to be, because they're not going to need a lot of sanding or any kind of post-process. So I want to put these on top. And now I want to go down here and see, well, I've got a square opening, but I could actually take this and let's rotate this part. Let's grab a little bit. And now I'm making these self-supporting as I go through the bottom. So that's going to help me get a good square bottom, and I'll have my opening there will be pretty good. I'm looking at my part. Now my part, I'm at a compound angle, so there's very little areas that are down-facing surfaces. And so that's going to optimize, and it's going to make my supports more something I can put in to help with accuracy, as opposed to trying to fight things and refresh, and I'm going to get a cleaner material. The other thing I'm going to get here, and I really want to stress this, is my cross-sectional area. Now, I used to do a lot of injection molding for about 15 years on different parts, large parts, small parts. And one of the rules that we tried to guide things by in the design is to try to get uniform wall thickness. Because if you get uniform wall thickness, then you're seeing the same kind of properties, and you're seeing the same kind of heat, the same kind of flow all the way through your part. And that sort of applies to what we're doing here as well. If I can go in here and look at trying to get a uniform wall thickness, you can see going up through this part, I don't have any of these big flats. In fact, that's probably my biggest area there, which I could rotate out of if I really wanted to, but I already know that we can probably print that pretty well. But I'll take and go through and check my part to see, am I mostly in the uniform wall thickness situation? Now, of course, every geometry is not going to get this, so I'm considering all of these things. I'm considering the intent and application of my part. What are the features I need to preserve? How do I minimize the cross-sectional area? How do I maximize my time if that's a part for printing? So I've got to consider those things when I set my part up. This is not something that I'll simply just load an STL, put supports on it, go hit print, and it's going to give me what I want. I really need to consider what I'm doing when I go through this. And so I'd like to reach success as soon as possible when I start my part. So if I consider that and do that up front, and it's one of the real reasons we're setting up and I'm doing these modules, is so I can teach people how to get in your lab what I get in my lab. Because when I set this up in my lab, how do I get success early? I get success early by considering things like this and setting my part up from the beginning with an idea of what I want this to look like in the end and why. And so once I get that set up, we can go in here and we can put supports on this. So let's just close this, and we'll go in and take our smart supports. In your supports, there's a couple of things I want to touch on here. When I open the support window, again, I set in yellow. Now this one says must watch, so I can't give up on that. Must watch best practices. I'm going to click on that. What's really nice here is there are a lot of videos that have been put in with these best practices. So in addition, we've added things in. So there's a training course here that you can go get more video information. There's some more best practice videos you'll see here. There's actually, in this system, there's an application guide for people that are doing jewelry. I will say that jewelry supports will always be manual, because jewelry has so much intricate geometry. This is not something you would hit a default and start printing your jewelry. You want to go in, if you're doing jewelry, I highly suggest going in and looking at this video. There's some sample rings and things you can look at for using jewelry in that application. But that information, again, is available when I go to the best practices here. In addition, there's a question mark. I'm going to hit that for help. And I can go through that icon and I see where anchor points are. I see how things are set up in 3D Sprint. If I go to the bottom of this, I can hit my other support parameters. This will also guide me through what these other terms mean in my support terms and how they're affected and what that looks like and how that can help me improve my part. What you will see for materials when you go into 3D Sprint, this was tough grade 10, it's got 3 different default supports. There's a fine flat tip, there's a general flat tip, and a general round tip. I will tell you, general round tip is normally for more robust parts, things that are really thick that might be more susceptible to warp. Fine flat tip, if you've got a really larger surface, say a big cover part that you want to maintain a flat surface area, it's got a lot of finer, you'll have more supports and more dense supports, but with a finer tip to make the cleanup easy, but you get a full coverage on that. And general flat tip is as it is. That would be kind of our default that we would set things at most of the time. Under each one of these parameters on the bottom is another set of adjustable parameters. Again, those are listed in the help section. We won't go through each of these. That's in module 4, but we'll go through this in a lot more detail and how to handle that. But let's go ahead and add create supports here. Once you have your supports on your part, then you can go over to your build style. Your build style also has a help button, and it will take you through the build style. And I know I'm really redundant in going to that help button, but I just want to reiterate there's a lot of help available in 3D Sprint. A lot of videos, a lot of things you can download and get answers to your questions. So you should never be stuck, at least most of the time. I don't like to say never. But under here, you've got your build styles. And so here you see your draft, premium, and standard. You can add build styles. You can also go down on the advanced mode. The advanced mode has another list of parameters where you can manipulate some of these. You've got your base layer. I will touch on base layer has a base layer curing time. A lot of these parameters, if you have any kind of adhesion issues, you may go in here and turn your base layer cure time up about 5 seconds, something like that, just to see if you can improve your base layer, or maybe to add like 2 or 3 base cure layers. And that will help your adhesion in the case of you got outside tolerances on some of your other hardware. But this just gives you a few more options on what you can do within a system, and if you do make a change, you can save it. And so once we're here, we chose standard mode. We're going to apply that. I'm going to close my view, and we're going to go over here and click on our print style. We'll take our print style to our save in my training folder. Again, this is a .pxl file. If it were a modular, it would say .f4x. We'll save this. My file is sliced. It tells me where it's located if I need to go get that. I'm going to go to my queue. I can add the file there. I'm going to browse. There's my file that we just sliced. We'll open that and add to the queue. And now my file's in the queue, and it will do an update and show me my file there. I can have multiple files in the queue, and they can be moved from the top and bottom and manipulated from there. One thing I want to go back and do, there are some things in 3D Sprint and Figure 4 printing that are going to be problematic. And so I want to be sure you're aware of what those are and what kind of parts these are and how and what that looks like. And one of the things that when we get into, I'm going to import this part here. And let's just go ahead and auto place that. One of the things when you get into this kind of printing is big blocky parts. In Figure 4, this is one of the more challenging type of hardware. And so rather than tell you that this will print everything, I would not do that to anybody. This is something that's going to struggle. So I look at the antenna of this part, and the antenna of this part looks like it's some kind of locating block that I can put down and locate features or some kind of jig. But when I look at the cross-sectional area of this part, that's huge. And that's really going to struggle to print in 3D Sprint. And so one of the things I can do is go to my transform. I can look at this, and we could transform this and turn it. That's still a big cross-sectional area. We can go back and do a compound, and we still got big cross-sectional area. So this part is really going to struggle to be able to print on the Figure 4. And let me tell you this, going back to injection molding, I would not injection mold this part because you're going to get a lot of parts sink and it's going to affect your accuracy. So if I know the intent of my part, and the intent of my part here was that I want to use this as a locating feature, then what I would probably do is come into the back of this part and core this out and put some ribs in here to maintain the structural integrity of my part, and then be able to get a more uniform cross-sectional area in some kind of compound angle setup such as this. So I really want to stress that if you've got really big cross-sections, you need to really take a step back and look at, okay, this technology is going to probably struggle with this as it is. So what's the intent and application of my part, and how can I alleviate that in the design? So I just want to touch on that. There's another type of part that you'll run into things on the Figure 4. And let's transform. Let's move this one around a little bit. We'll go to our Orient. And we'll set this up. Now this particular part, as you can see, it looks mostly uniform, but if I go in here and hit this, and I go start looking at what my cross-sectional area is, it looks pretty good there. Then all of a sudden, wow, that's going to be a problem. And if I rotate this, it could still be, I could probably rotate this to get mostly out of it. But one of the things I want to be considering, if I look at it in this orientation, is differential shrink. And we'll talk about that a lot in additive manufacturing. And one of the things you'll see is, let's say this particular material has a 1.5% shrink. I'm not sure exactly what it is offhand, but let's say it's 1.5%. Well, if all I'm printing is this section down here, then I'm not going to have a lot of difference here in how this shrinks. I'm not going to see that very much. But if I'm going up and going up and going up, and all of a sudden I get to a layer where it starts this, wow, 1.5% of this is really going to make a difference. And it's going to come in a little bit. And what you'll see is your part will come up, and it's going to come in this way. And so you'll have these bottom pulling at the center, and it's going to have that shrinkage. Then it's going to get out of it, and you're going to bow back out. So you're going to have kind of a shape like this in your part. And so one thing you want to really be able to do when you're doing this is go in and look at the orientation of your part and see, can you orient out of anything to get a more uniform wall thickness? That's a lot better there, and you're going to see a little bit less differential shrink in this particular part. Now, differential shrink is a material property, and some materials will have more than others. But the advantage to understanding the intent and application of your part and understanding how the figure 4 systems works, you can set it up to minimize what you may or may not see in that situation. So it's something to consider in your part setup that's really important, and I just wanted to be sure to highlight that. All right, well, that concludes all the information I have and the things we have for Module 2. Again, as we go forward, you'll see us doing the other modules, and we'll go in much more detail in the next Module 4 for building parts and the advanced styles and supports, and some of those styles we'll do that in the Module 4, and then we'll add on to that as we do combination parts and things like that as we go forward. So I really hope that you were able to grasp the understanding of the basic 3D Sprint toolkit, all the help that's available, where the hot links are, some of the things to pay attention to. There's a lot of information we went through here today, but a lot of it is redundant, and you'll be able to go back and find that, as well as come back and watch the video, and you can see where we pointed some of these things out.